Here's an interesting problem. 5 students are divided into 2 groups of size 2 and 3. Basically, we're splitting this group into 2 smaller groups. The students are A, B, C, D, and E. And the question is, what is the probability that these 2 friends A and B belong to the same group? Pause the video, try this out. Okay, so let's do this by brute force first. Let's list down all possible scenarios. In how many ways can we split 5 into these smaller sizes, 2 and 3? We can select 2 out of 5. That can be done in 5C2. That's 10 ways. So we'll have 10 scenarios. The first one could be A, B, and C. That's one group. And D and E, that's the other group. This is actually favorable for us. In this one, A and B do belong to the same group. And we can list down all 10 of them and see where do we have A and B in the same group. We have A and B in the same group in the first 3. Where else do we have them? Here's AB. A and B belong to this group of size 2 and C, D, E belong to the other one. No other scenario work for us. So 1, 2, 3, and 4. 4 out of 10, that's going to be 40%. So by listing down all possible scenarios, we see that the probability that A and B belong to the same group, that's going to be 40%. But how do we make sense of this without forming this list? Here's an approach. Let's allot these students roll numbers from 1 to 5 and say that roll number 1 and 2 is group 1 and roll number 3, 4, and 5 is group 2. That's the other group. Shorter group and the larger group. Now our job is to select roll numbers for our friends A and B. Total number of ways is to select 2 out of 5 total roll numbers. That's going to be 5C2, 10 ways. So we can select 2 roll numbers out of the 5 in 10 ways. So this is going to be our denominator in the probability. For the numerator, we're going to look at favorable ways. Either we can pick 2 from this first group or we can pick 2 from this second group. Selecting from the first group, 2 out of 2, 2C2, that's one way. We select both of them. Selecting from the second group, that's 3C2. This is actually 3. So there are 3 ways to select 2 out of these 3 roll numbers. In all 4 of them, 1 plus 3 is 4. In all 4 of them, we can say that both A and B belong to the same group. So favorable is 4 and total scenario is a 10, which means our probability is 4 by 10, 40%. So what's the probability of A and B not belonging to the same group? They belong to different groups. Well, that's 100 minus 40, that's going to be 60%. And what if we change the values? Now what if we increase the size of these groups? What is the probability of them being in the same group if the sizes are 40 and 60? Pause the video, try this out. Okay, following this approach, let's select 2 roll numbers. Selecting 2 roll numbers out of 100, that's going to be 100C2. That's 100 times 99 divided by 2 times 1. That's going to be 50 times 99. That's 4950, 4950. That's the total number of selections. And for favorable selections, either we can pick from the first group of size 40 or we can pick from the second group of size 60. So selecting from the first group, that's 40C2. That's 40 times 39 by 2. That's 20 times 39. That's going to be 780. So there are 780 ways to select 2 roll numbers from this group of size 40. Similarly, selecting from the second group, that's 60C2. That becomes 1770. So there are 1770 ways to select 2 roll numbers out of these 60. So our favorable scenarios, 780 plus 1780, that's going to be, this is 150, 850, 17 plus 8 is 2550. So favorable scenarios 2550, total scenarios 4950. Dividing, we get the probability that both A and B belong to the same group is equal to 51 by 99. That's 17 by 33. That's equal to approximately 51.5%. Now, when I first solved this problem, I was surprised that this number came very close to 50%. And I asked myself, what would happen if the group sizes were 50 and 50 each? And that's the next question in this video. What is the probability of them being in the same group if the sizes are 50 each? Do you want to give this a shot? Pause the video. Okay, let's do this together. Selecting from the first group and selecting from the second group. For both of these, the answer is 50C2. That's 50 times 49 by 2 times 1. That's going to be 1225. So 1225 here and 1225 here. So total favorable scenarios is twice of this. That's 2450. And if you find the probability, 2450 divided by 4950, that becomes 49 by 99. Now this is approximately 50%, but this is not exactly 50%. And when I looked at these values, I had a hunch that there's some ordering between 40 and 60 and 50 and 50 for which this probability is exactly 50%. And this is where I couldn't stop myself. So I figured out the probabilities for all possible group sizes, from group size 298 to 50-50. You can pause the video and observe the probabilities. Okay, let's do this together. The probability is highest if the group size is 98 and 2. And that makes sense. If the class is divided into these group sizes, size 2 and size 98, there's a very high chance that most students will fall in this group, the group size 98, which means that there's a very high chance that you and your friend end up in this group. So the probability that both of you will be in the same group is going to be 96%. That's the highest value. And when we change the group size, when we increase this one and decrease this one, the probability reduces. It goes all the way down to 49.5% when the group sizes are both 50 each. This is 50-50, which is 49.5. That's what we had. You can also look at 40-60. For this, the probability is 51.5% approximately. And between these two values, there is one value, 45-55, for which the probability that both friends are in the same group is exactly 50%. And this is where I would leave you thinking about this. Why did the answer 50% come at 45-55 and not at 50-50? Think about it. Maybe we'll pick this up in some other video.